Welcome to the second of four Nanovember lectures that we'll be giving here at CNSC this month. Today we're going to talk about the creative parallels between nanochemistry and jazz. And let me say it's a real pleasure to be here. We've been working on this for a while. It's really great. Finally, the day and the moment has already arrived, and I can see right now that you are a lovely audience. So I really appreciate it.
We'd love to take you home with us. But I don't really want to stop the show.
My name is Robert Brainard. I'm a professor here at the College of Nanoscale Science and Engineering, and I specialize in nanochemistry. And I'd like to start by introducing my good friend John Chmaj. He and I met in college. We were sort of assembled into a quartet at UC Berkeley in California. And he and I became fast friends, became roommates, and formed this band. And then we both ended up moving to Boston at the same time. I went to MIT, went to Berkeley School of Music, and then later to New England Conservatory, where he got a master's in composition and theory. Okay, and currently John is working in high technology. As a consultant.
And Robert and I met when we were literally in our 20s just a few years ago. And we've been playing ever since, on and off, for about 30 years actually. We played in a whole different bunch of bands, all named after some chemical name. There was Covalence. You had a couple more. What
no, mainly Covalence.
Was
I kept reusing that one.
Yeah, that was a good one. Yeah. And so we've stayed in touch. I live in Seattle now, but it's just been a real delight to come out here. And Robert and I actually got a chance to play with his band over the weekend, and I actually brought my son up from New York City. He's 18 and learned how to play the bass. Robert let him play in the band, and Angus let him sit in. And so we're just passing on the tradition here as we go. It's been a real pleasure to get ready for this presentation because I've watched Robert do chemistry for quite some time, and he really does think about these things in similar ways that we're going to share with you today. And he's also now introduced me to his latest musical ensemble, the folks in his jazz group.
So I'd like to also go back to start a little early, I guess.
We're good.
Yeah. I'd like to start. I've been here at the college for 4 years, and my anniversary is just passed. And I think back on my first day on the job, and I was sitting at my desk, and people were saying hi to me, and somebody said, "Oh, you play music? Yeah, I think Angus plays in this room." Go, yeah? Yeah, I think he plays bass. I'm out of my seat. Yeah, string bass. I'm running down the hallway. I go there and I introduce myself to Angus. And Angus and I have been playing together for the past 4 years. Ever since, we're co-leaders of the group Jasmine Quintet, who plays in the area. Oh yeah, it's going to be on this slide. And Angus is a business manager here at the College of Nanoscale Science and Engineering.
Yeah, as it often happens, Robert and I were playing a gig at a friend's house here in Albany, and they said, "Hey, guess what? There's a drummer here." And we said, "Let's go, bring him in," because we didn't have a drummer at the time. And Bob Cassell came in and sat in with us, and it's been a love fest ever since. So we're happy to have him.
So today we're going to talk about the relationship of jazz and chemistry, and it may sound like two very different topics, but they have one common theme, and that is creativity. We're really all about trying to create something new, something different, something that is evolved from our experience but hasn't existed before. And so we're going to talk about the surprising similarities, when you really think about it, what the creative process means. Even though it's something technical and very complex in a laboratory environment, it may seem rather off the cuff in a jazz environment. There's actually quite a few similarities, even despite all those differences in how long it takes to do chemistry versus a jazz song. And if you look at the creative process in terms of the basic thing you need to do and the kinds of things you have to have a handle on, there are some real interesting similarities and some differences that we'll talk about. And we'll try and explain to you how we think about this today. So in order to get a handle on that, let's start with some vocabulary. I don't know if everybody here has played music, if you're used to playing different different instruments at all, but music has a vocabulary. It has a language. It's got its own little lingo of a staff and notes and notation and things like that. So as you go through, you can notate what it is that somebody should be playing, and as the different notes are high and low, and you can basically create a whole palette of things that you want people to do. And if you want, you can go low or even lower. Show off. So that's actually off the horn. That was actually a sonic experiment. They don't know. But it has its own vocabulary, just like the chemistry does.
And just as music is composed of individual notes, chemistry and molecules are composed of individual elements, such as hydrogen, carbon, nitrogen, and oxygen.
So basically, there's a basic background structure, of course, to chemistry and to jazz. And there's even goes a little bit step further is when you start to combine these elements together. Now in music, when you combine these elements together, you get what we call chords, or combinations of notes. So there's a cluster that fits together, has a certain flavor to it. If you create a different one, it might have a different sound, a little richer. It's a minor chord. Or you could have something that's a little more beautiful and high, like a major chord. So there's a whole series of vocabulary that fit together and then have common structures or harmony inside of them. That's somewhat similar to what you might think of when you think of molecules in chemistry.
So just as chords are composed of individual notes, molecules are composed of individual elements. So a lot of these molecules, we know in common in everyday life, such as water, and aspirin.
I have a headache, sorry.
Caffeine, chocolate.
I like chocolate.
And notice that these two molecules are very, very similar to each other. They only differ. This one has a H3C group here, and this got a hydrogen group. But the rest of the molecule is very similar, and they both are stimulants, and they both have sort of at least in my mind, a kind of a dark flavor. I like to mix my chocolate with my coffee, but anyway, these are the two molecules that we work with. One of the things that we're going to talk about today is we're going to talk about examples of molecules in chemistry in my research here at the College of Nanoscale Science and Engineering. And here are three molecules that I call acid amplifiers. Okay, each of these molecules have their own chords, obviously.
Absolutely. Everything's music today.
So anyway, we'll be talking about those throughout the lecture today.
We're also going to talk about jazz. So I don't want to make any assumptions that everybody knows what jazz is. What is jazz? What do you guys think jazz is? What comes to mind? If I say jazz, what do you think of?
Style of music.
Improvisation, a style of music. What else?
Beat.
A beat. Okay, a beat.
Swing.
Swing.
Swing, yeah.
I think that's a great example, right? It's funny that you think of a beat when you think of jazz, right? I mean, if I say classical, you don't say swing, right? You don't say I think of a beat, right? But you do when you think of jazz. And I think all these things are really true, right? I mean, jazz is a combination of things, right? It's a historical American music. It's an art form that evolved from the early 1920s and 30s and became an art form with its own vocabulary and its own body of music. But it's also an approach to performance that includes improvisation, as we just talked about, includes live performance is really important, right? You got to get out there. But most importantly, it's got the swing, right? As Duke Ellington said, it don't mean a thing if it ain't got that swing. That's actually the name of the song. Yeah. I mean, it's got to have it, right? And you can think of it as a way of living, right? So if you live with swing, then you're jazzing, right? And Charlie Parker was a very famous jazz musician. He said, if you don't live it, it won't come out of your horn. And so think about that. So how do I play my life experience? What do I do to create this life experience that I have? What am I going to do? How am I going to do it? Well, there's a series of essential elements. One of them we just touched on, the groove. You got the groove, right? Now, the groove is just the background to the tune, right? That doesn't mean anything if I don't have feel. things working together. You got to have the feel, you got to have a handle on the music, you got to be able to make stuff up, and most importantly, you got to have some energy and some emotion around it. So let's figure this out for ourselves. How are we going to do this? Let's make up a jazz song. Ready?
Yep.
Okay, you start. Well, I really meant it. You got to start. So let's talk about the blues, right? The blues. Everybody knows what the blues is. What's the blues? It's a feeling. Something I don't like. Something bad happened. I want to sing about it. All right. So what bugs you? Come on, tell me something that really just.
Let's see, show of hands. Who's got something that they want to
No,
talk about?
tell me what it is.
You can write a blues song about the economy.
The economy. Excellent. What about the economy don't we like? It sucks. Can I say that at the Society?
No, we can say that. He's an economist, so he knows.
Suck a technical term? I don't want to get too above their heads here. Economy sucks. What else? Anything else about the economy that bugs you?
It sucks. No jobs. Out of work.
Unemployment?
Employment.
Okay. All right.
It also provides opportunities.
Opportunities. Well, hey, so now we have the foundation for a song. We know the economy's really, I got the economy blues, right? Right? It really sucks, why don't you walk a mile in my shoes, right? But new things might happen, right? There could be good news. So here we go. The economy sucks. Don't you know the news? I say the economy sucks. Walk a mile in my shoes. I ain't got a job. But hey, could be something better. There might be good news. Right? So we just made up a song. Great. I might be soloing for a while before the new good news shows up, but we'll keep going. So now what do I do with that? Well, now I've got this tune. We can do all kinds of things with it. I can do so I did, right? So I can do something like, make up a little motive or a little idea and just work it all around. Or you could even get really creative with it, Right? Make up a harmonic thing that works through it, right? And before you know it, you got all these ideas percolating around. And believe it or not, when you get really good at this, you can just start doing it live with I didn't tell these guys to start playing. That wasn't even at rehearsal. They can't help themselves, right? They're used to reacting as a musician in a jazz context. You just take what's happening and you go with it, and you see what happens. So you experiment. So we're already in the lab. Isn't this great? And we already had one experiment. It was a successful experiment. We had output, a hit record. You topped that. So seriously, it's very important to understand that there's a creative process that goes on. And we're going to talk some more about that. But it's really easy to get a handle on when you think of it in terms of just the basics of what we do.
So now, I thought this would be a good time to to talk about some definitions. So what is nanochemistry? I looked it up in Wikipedia, and it's basically the synthesis and characterization of chemicals at the nanometer scale. What are we talking about? Nanometer, what are we talking about? Well, let's start with a meter. People are generally about 2 meters high, tall. If you take a meter and divide it into 1,000 pieces, oops, I went too far. You divide it into 1,000 equal pieces, you get a millimeter, and a penny is about a millimeter thick. And if you divide it into 1,000 equal pieces again, you get about a micron, and a blood cell, red blood cell, is about 6 to 8 microns across. And you divide a micron into 1,000 equal pieces, you get a nanometer. And a nanometer is sort of on the atomic scale. If you're looking at a silicon surface as we are here, 5 silicon atoms in a row is about a nanometer. And then another thing that's a nanometer is one of the molecules that have been developed in our group. Here's a acid amplifier. It's about a nanometer across. And so I'm going to tell you a little bit about the research that we do in my group here at CNSC. One of the things that we work on are resists, or photoresists. And this is a picture of some photoresists. You can see that the width of these, the numbers here indicate the width of the line. These lines are about 120 nanometers wide, and these lines are about 80 nanometers wide. Notice that the thinner lines are so thin that they're falling over. But this is a photoresist that's used in the microelectronics industry to fabricate computer chips, integrated circuits, things like that. And so the whole idea of these photoresists is to make things as small as possible. The smaller we make them, the more transistors we can put on a chip, the faster the computer that we make. So it's all about resolution and making things small on a nanometer scale.
I actually had to start on the list. So we've got this idea of creativity in jazz. We're going to talk about how Robert does creativity in his chemistry. But let's start defining that a little bit more carefully now. So what actually is creativity? I mean, what do you think of when you think of creativity?
Thinking out of the box.
Thinking out of the box? Something new? Something unusual?
Flashes of inspiration.
Flashes of inspiration. That's interesting. The aha creativity.
Different way of doing things.
Different. So creativity is something different. So it's not doing the same thing, it's something different.
Producing something new.
Something new, so there's out of the box, flash of inspiration to create something new. That's interesting. So we've all had a creative moment at some time or another where we've done something that we think is new and meaningful, right? I mean, I've done creative turns in traffic that weren't that meaningful. but right, something that led to a good outcome. You're going to talk about that. And believe me, in jazz, there are a lot of wrong turns. You take them, that's how you find out where the right turns are sometimes. Well, from my perspective, it's more of a state of mind, even what we were all just saying, thinking outside the box, thinking of something new, flash of inspiration, all has to do with what's going on in our mind, doesn't it? It has to do with a state of mind, and you have to have a certain type of capability to be open to the possibility of the new thing, right? You have to be aware of what's possible, but you also have to be knowledgeable and prepared enough to know something different when it shows up, and to be able to take advantage of it. Otherwise, it's just meaningless, right? Something could happen in front of you, you wouldn't even know that it was something you could take advantage of. And so you have to be kind of open and ready for action, but you also kind of have to be playful. You have to think about things in a way that, you're not judgmental. Maybe this will lead to some other place. I might try some crazy idea, and suddenly it turns into this beautiful new song, right? So you have to have a state of mind where you're really kind of playing with ideas, ready for whatever happens, and being prepared, but also not afraid to make mistakes and try new ideas. So it really is a state of mind.
So I also put my 2 cents into this discussion, and John and I are always talking about these things. So I came up with my own definition of creativity, and I would say it's the synthesis of a useful new idea or object from a set of pre-existing ideas or objects. So, but one of the words here is useful. In the world of chemistry, there's probably about 5,000 new molecules made on Earth every day. And so the complexity that's possible in molecules, it's possible to make things that have never existed on the face of the Earth. But to me, the challenge is, in the more interesting way to look at the creativity is to try and invent something, think of something directed at a specific problem or a set of criteria. So that's where I come in with useful. And to me, that's when, in terms of the creativity that goes on in my group, the things that really excites me and excites the members of our group is to try and solve a problem, which makes it a slightly harder, more difficult task. Okay, so now we'd like to we move into a section where we talk about structure and some of the structures and some of the similarities between chemistry and jazz that are shared. And we want to start with waves. So everyone knows about water waves. If you drop a pebble in a pond, you get these waves, which is basically periodic disturbances of the surface of the water, but they're periodic. And then sound waves, of course, are a very important part of music. And sound waves, just sort of the physics of sound waves is usually you have something vibrating. In this case, we have a tuning fork vibrating. And what it does is it smashes into the air molecules and kind of compresses them. And then those compressed air waves move at the speed of sound, and then go and reach our ear and bang up against our eardrum, and we sense that as sound. And then there's light waves, which are also periodic, that vibrate, or will have vibration and frequencies, but in this case it's electromagnetic, and it doesn't need air for light to travel. It can go through outer space.
So that leads to an interesting question. Why do we call these things instruments? Why do we call it the music maker or the music fun thing? It's an instrument, it's a tool. It's very similar to what you might have in a lab, right? Except we have a different kind of lab. Our lab serves drinks. So here Hank's going to show us his instrument, his tool that he uses all the time. What kind of sounds can you get out
Okay,
of
this
this?
is an upright bass, and you can produce sounds in a couple of different manners. One is called pizzicato, which is where you go, you just pull the string. The other way is to take a bow and drag it across the string. There's a third way that bluegrass musicians use, pardon me if there's anybody out there, bang on their piano, on their bass. So the string, the sound basically transmits from the vibrating string to the bridge, down into the top, through a piece of wood that connects the top to the back, and it all vibrates. And as you get a shorter string, you get a higher pitched sound. And then you can get overtones out of the instrument as well by playing harmonics. Useful in some instances, but all produced by the sound waves coming out of the holes here in the front.
Thank you. Okay, so that's a discussion of sound waves. Now I want to talk a little bit about light waves and how they correlate or are used in nanochemistry. I mentioned earlier, here's a picture of photoresist that we're trying to make features that are as small as possible. And here is a picture of some light waves. So we have on this blue curve, which is a relatively long wavelength light, a frequent wavelength of light. And here's the red one, which has a relatively short wavelength of light. When we try to image a photoresist, the way it works is we pass light through a mask, and it creates acid, and then we bake it and develop it, and we make these features. But in order to get through and we make the mask features smaller and smaller and smaller, so we can make smaller features in the resist. In order to get the light through those masks, through those openings, we need a shorter wavelength of light. And so here is several well, this is most if not all the electromagnetic radiation, which scientists know as light. And it goes from radio waves to gamma rays. And in visible light is right here in the middle, red, green, and blue. And even the visible light that we are used to has different wavelengths. Red's about, actually it's not 700, it's probably about 650 nanometers. And blue is more like 450 nanometers. And with the different wavelengths of light have different energies associated with it. Now, in my research, I use EUV light, extreme ultraviolet light, which has a wavelength of 13.5 nanometers. And in fact, the College of Nanoscale Science and Engineering is one of the, I would say, premier places on the planet to do EUV research. And the reason for that is that we have two very specialized exposure sources and, two exposure machines, steppers, and two other sources. So we have 4 different sources of EUV here at this tool, at this facility, and I think probably the next closest place in the world has only 2.
Cool.
And
I
so
think we should have a slogan at University, come see the light.
So,
Rim shot.
So I want to talk a little bit more about acid amplifiers that we do in our research. Now, one of the things that we want to do is make lots of acid. If we make just a small amount of acid, then we have to do, each acid molecule has to do more work, and it has to fuse out, and when we do this, each acid makes a big bite out of the resist. And when it takes a big bite, we don't get as good of resolution. But if we have more acids, and we can design those acids to not move very far, then the bite that each acid takes is much smaller, and we can get better resolution. So one of the ideas is to make more acid in here. And the way we do it is we use molecules called acid amplifiers. And an acid amplifier will take one little acid that was originally generated by light, and it will double it. And then it'll take those two and make 4. And so we can get a lot more acid from just a single photon. And we can go from a situation like this to a situation like this. Okay, so this leads to our research, our research in this started about 1.5 years. And in the first 6 months of our research, we made no acid amplifiers. We were not successful at all. We had lots of good theories, we did lots of experiments, and none of them were successful. We kept trying to make these we could draw a molecule, we try and make it, we make it, and it didn't behave right. Either it was not stable, or it didn't generate acid the way we wanted. And so, we kept thinking about our experiments, and these experiments that didn't work. And so the key thing that helped us move forward here was we were able to simplify. We had to simplify our thinking. And we simplified our thinking by thinking of the molecule as having 3 parts. Having a body, a trigger, and an acid precursor. Once we simplified our thinking, we could sort of do a theme and variation approach to this chemistry. So once we said, okay, we have a body, okay, well here's these kind of structures we can use, and they should be suitable bodies. And we can say, okay, we need a trigger, and these are the kind of molecules that we thought of, and we say, well, what is the trigger supposed to do? And we could design the molecules in these little pieces, in this sort of a module approach. And we could also say, okay, we also need an acid precursor, and so we thought about all these things. Once we thought about these various parts, we could assemble them together and make lots of acid amplifiers, and once we did that, we were successful. In fact, since we made the first of these molecules, which I'm just going to go back one. Oops. We made this one first. If you will, is the theme. And then once we took this approach, we could do many variations. And even though I had 12 molecules here, so this is one here and that's one here, we've actually made 40 new molecules that never existed on the face of the earth, and they all act as acid amplifiers. And we have different flavors so that we can use them different ways and in different situations to solve problems.
So this is really interesting because this approach is very similar to what composers do when they want to write an extended piece of music. They take the idea of a theme or some kind of a basic musical idea, and then they deconstruct it. I was listening today to the Goldberg Variations by Bach. He wrote them for a friend of his who was ill, who was sitting by the bed and couldn't move around much, but he wrote some music that he could listen to, and he took one simple little theme and wrote 32 different little variations on this one theme. And basically what you're trying to do is evolve an idea just like Robert showed with whatever its basic characteristics are there. You know, is there a body of the harmony in the structure? Are there triggers of things that move along that you can pull apart and redo? Are there different combinations of these things that you can make that create the new variation? And so this is a very interesting process that's done. It's age-old in tradition in classical music, and it also is a tradition in African American music. In the blues, the thing we just made up was really a theme and variations, wasn't it? We just sang a little line, and we sang something similar, and then we kind of rolled it out, and the variation on the variation before you know it. So it's a common practice, and in fact, jazz musicians, when they get good at it, can do this in real time, right? And we're going to illustrate that right now with a song by Lester Young called Jumpin' with Symphony Sid, which in itself is a really simple theme and variation. The theme is, that's it. Well, there's little rules, a little trick you should know. And this is kind of part of the insight from your chemistry. The simpler the idea, the more things you can do with it. Remember what he said? He simplified the idea, and then he could develop the variations. Well, what's the next line? Right? That's the whole song. Now you're going to hear that little teeny piece turned into a theme of variations, and then we're going to do something we call trading fours, which means we're going to trade 4-bar measures each and make our own little variations through the tune. So here's Jumpin' with Symphony 6 with Trading Floors. Go ahead and count.
1, 2, 1,
That's great. Take 4. Symphony 6. Couldn't help taking an extra chorus. Huh? Yeah, I'm in the bank for one now. I get one. All right. I've known him 30 years. He says there's nothing, no end to the abuse he needs to take from me. Here, even in his own college, the professor of nanochemistry. Why he invited me, I have no idea. But we're actually having a lot of fun with this musical idea. So let's talk about what it is that makes this thing happen. Well, the main thing underneath that was the groove, right? The rhythm. That's the thing we played under. And if that had stopped, we all would have gotten uncomfortable. Believe me, including the band. But let's ask Bob how do you do this rhythm thing? What is that?
Robert and John forced me to think about this. But thinking about it, what I come up with, it's a rhythm to me is a repetitive pattern of sound that along with the bass, provides tempo and a groove or feel, pulse for the song. And of course, it's all within the context of the style of music you're playing.
So we played swing, right? So let's hear a little bit of that. Right? But we could do the same song in, say, Latin, right? So we do 2, 3, 4. Get the idea, right? You could do a rock thing. Right? You could do anything with this thing, right? How about a waltz? That's clearly not going to be a hit. Wait on. You have to make good choices, just like in chemistry. But the important thing is that there are these repeating patterns that you can do that give the pulse to the music.
And it also gives some predictability for the other musicians to play around that pulse,
You really are the bottom of
along with the bass.
Yeah, and so in thinking about this and looking for parallels, we thought that the best parallel in chemistry is maybe a repeating pattern in a polymer, such as shown here. In this case, I have a styrene. This is a monomer that can be polymerized to make styrofoam, or polystyrene. And polystyrene can be used to make styrofoam, which is used to make coffee cups and things like that, surfboards. And you can also make, combine things in polymers, and they can do alternating A group then B group, or A, B, C group, or all these things that have a certain rhythm to them and a certain repetition. In preparing for this, I thought about, what is one of my favorite examples of nanochemistry? And I thought about the work of Professor Wilkow at University of Alberta. And he's done some really interesting things, where he takes a silicon surface that has a little defect on it, which we call a free radical, and this styrene molecule is the same thing that makes polystyrene. And so it reacts, and the little defect moves from the surface to the molecule, and then it reacts again, and hydrogen moves over there, and we get a defect back on the surface. And so now it can react with another molecule, and then that reacts, and the defect's back on the molecule again, and then it goes back to the surface. It goes on and on and on. And Professor Woolcall was able to do this and make a movie out of it. And so these are actual individual molecules, right here.
They're grooving.
Individual molecules. When I first started chemistry, people told me there is no way you will ever see a molecule. It's just not possible. But now today, with nanotechnology, it's possible. It's using a scanning tunneling microscope. So these are individual molecules of styrene that are binding to the surface. And notice they have their own, not only is there a spatial repeating pattern, but they have their own rhythm. And you can see that this is, that they didn't, in filming this, they didn't alter the relative speeds of this, and they just go pop, 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 with a little rhythm that these molecules have.
So there really are some interesting comparisons in terms of the way in which you not only think about creating material, but actually in the medium themselves and the way in which things line up in repeating patterns that you can think about. And there's actually some interesting combinations if you step back for a second and think about the differences between jazz and chemistry in the creative process. The concept of experimentation is very fundamental to both disciplines. In jazz, it's learning by doing, right? I mean, we figure it out as we go, right? There's this real-time experimentation that's happening, and there's this sense of, if I have a lick, I'm going to learn it, and I'm going to try and use it again and build a solo off of it. And so this concept of experimentation is really fundamental to the ability to create some new music. That's what it's all about.
And clearly in science, we run experiments. We run them every day. And usually an experiment starts with a question or a hypothesis. Gee, if I combine A and B, will I get C? And usually we have some sort of anticipated result. And so we do this, and what we learn here is sometimes you don't get what you expect, but you learn something. And even though your theory may be wrong, you learn something, and you say, okay, well, my theory's wrong. Why is that? And you start building these little islands of knowledge or stepping stones of knowledge, and you build a whole composite of understanding about a certain area or something that you might be working on. Now I want to move on to improvisation. In general, in chemistry, the time scales, as John mentioned earlier, is very different, right? A jazz song might be 2 or 3 minutes, whereas a research program might be 2 or 3 years, or maybe even 6 years, 10 years to do a certain amount of research. So the time scale is very different, and so if everything's going well, one should be able to predict the future a little bit and anticipate things and plan ahead, but things don't always go as planned, and usually they don't. And so you try and plan ahead, and that'll get you so far, but generally you find that you're up against a deadline. You need to write a paper, you need to get a sample ready for some exposure time somewhere on a very expensive piece of equipment, and so you have to innovate. And sometimes, the research group that I work with and I will get together, and we have to accomplish something. We have to accomplish it within a certain amount of time, and so we innovate, and people will work together as a team and move forward.
Improvisation may not be quite as magical as you think it is. For those of you that have never done it, often people think it's just, you have this talent that you suddenly can improvise. It's actually a composite of all the little things that you've learned how to do that you can bring into the picture and create in real time as you need it. So it's really a form of structured composition if you think about it. It's really not necessarily as magical as, this suddenly showed up in my head. It's more like I'm up against a deadline. It's called the bar line. It's the next part of the song, and I've got to execute something in about 10 seconds or even 2 seconds. So I've got to get busy making it fit. And so if I've got what jazz musicians do is they evolve these little patterns, or what they call licks, or phrases that they can use over and over again. And you hear it in any of these guys that play. You hear it in our playing. There are these little patterns that we play. So the creativity comes in how we structure those things in real time to either build up energy or make sort of a more elegant statement or whatever it is we want to do. So the improvisation really does have a structure to it, but it really is up to the performer how they want to exercise the pieces, the vocabulary that they know about. And we've all heard perhaps people that are less interesting to listen to. It's because they probably don't have a whole lot of interesting new ideas. You feel like they're playing the same thing over and over again. You can tell when someone is really onto something or not.
So mistakes.
Now, occasionally, every now and then, we make mistakes. We haven't made any today, right?
Right.
Thank you.
Excellent. You want to turn off the tape recorder. But the funny thing about mistakes is that in jazz, they can lead to really interesting ideas. In fact, in music in general, mistakes are something that if you, as a band, don't let on, oftentimes you can get away with. I used to play in a top 40 band that played pop music, and whenever anybody made a mistake, the rule was everybody else would turn around and go, "Yeah!" and then the audience got really confused. They thought they knew the song. But obviously we're having a good time. And then the second rule was play it twice. Then it really, I can't believe it. The Beatles wrote that. So you basically would cover up for it. But the idea was that you were trying to basically move forward through this mistake. But in jazz, it's far less of a transgression. It's actually quite interesting. If you can play something you haven't thought of before. Ornette Coleman was a famous free jazz sax player, and he actually said, I realized I was onto something when I could tell the difference between a mistake and something that wasn't a mistake, because I could tell what I was supposed to be playing, and it helped me figure it out. Oftentimes, jazz musicians, I can't tell you what I'm going to do on the next song coming up in a minute. I have no idea, really. I mean, I hope I know what song I'm playing, but other than that, I really don't know. Miles Davis is a famous jazz trumpeter. He made many, many records. And he was in the studio once, and the guy on the other side of the glass wall was bugging him. What are you going to play? What's next? Because he wanted to write it down. Miles finally got tired. He said, I'll play it and tell you what it is later. That's what he said. And it's on the record. That's the funny part. It's If I Were a Bell. If you look it up under the Cookin' record, the whole record starts with, I'll play it and tell you what it is later, which is kind of cool. They left it on. So mistakes are kind of interesting in jazz.
And mistakes are important in science. I'm always encouraging the students in my group to explore and not really worry about making mistakes. I don't really think that's the right way to go about doing research in for graduate students. That they should, if they have some ideas, go out and explore them. I want to encourage them to do that. And so, I'm thinking about the example that I think about was one of my students, Brian Cardinal. When he first joined the group, with first student, I told him specifically, I want you to do this reaction, okay? And you'll combine A and B, and you'll get C, and it'll be great. So he did that. He got A and B, and then he showed me the spectrum, and he's going, I don't think this is C. But it was a very, we can look at the spectrum, and it's very simple because it was one pure compound, and we couldn't quite figure it out. We thought about it, and we finally figured out what it was. And what we made was a bit of a surprise to us, obviously, and much more valuable than had he made what we wanted him to make. And in fact, Brian and I have a patent, or have submitted a patent application for this work.
Now, the other thing that's interesting about the environment in which these things take place is that the audience does matter. I don't know if you've thought about it, but you're actually part of the show. I mean, we've gotten a few laughs, a little applause. We're feeling comfortable. You guys comfortable? Feeling happy? Yeah. We played a social function on Friday night that was very laid back and sort of formal, and we would play a song, get done, and nothing. All right, play another song. Even harder, get done. Now, these folks were having a great time. They were happy with the music. There was nothing wrong. It wasn't an event where they were going to applaud. But we were kind of like, geez, what are we doing wrong? You can't help it when you're performing, right? You want a little bit of feedback, right? You need that, and it influences what you do, right? It also matters what's going on in the band, right? You got to have guys you like playing with. You got to feel good about what's happening. I don't know if you heard me a couple times in Rob. We encourage each other because that's how we create something new. Is the energy that we do together. Now Saturday night, Robert and I got to play down at the Tap and Tea down in town. And that's more of a noisy place. You ever been in there? Lots of energy, lots of people walking around. There's, all kinds of action. And there was all kinds of applause and noise, and we were having, which is great, right? And we played louder. We definitely played with more energy. And I stayed awake. So it was a good outcome all around.
Yeah, I think we have a few people who were at the gig on Saturday.
Right. Those of you that were there Friday, I had no offense to the bride and groom, but it was actually a really nice event. It was just a different environment. And so the environment has everything to do with what you do. In fact, even the room has a lot. I mean, Bob was mentioning how much he likes this room. And what do you look for in a room to sound good?
To me, for the sound of my drums, it's very important. Maybe the most important thing is the room. How big is the room? How high is the ceiling? Is it acoustical? The walls, are they acoustical or are they brick or cement blocks? The floor, is it carpeted? These are major factors for the drums. It's not as enjoyable for me personally to play in a room that the acoustics aren't right. And there was another.
You probably feel like you're playing a big giant drum set in a big boomy room. Right?
Yeah.
You're probably afraid to play.
Yeah, and of course, I forgot. The people actually can crowd more people in a room. It affects the acoustics, so it matters playing in an empty room versus a crowded room.
So you're actually part of the show.
Yeah.
And you sound very nice.
Now, if I can say from a nano, I'll go from the
Yeah,
script
yeah.
here. So from a nano point of view, I was thinking that I can't measure this, but if one of the persons in the room left or came in, it would affect the sound of the in a nano way. I can't measure.
Yeah. Well, we're still working on that particular instrument. Okay. Oh, yeah, my turn. All right. So, and then an audience is important in science as well. Obviously, if you know who's listening, who's paying attention to what you're doing, you may say something different, depending upon which students you might have in your class. If a scientist or a graduate student is giving a talk at a conference, and they know that Grant Wilson's going to be the audience, and so you might change the way you present that. You may also change the way you write a paper, depending on perhaps what journal you're going to be sending it to, and it could be a very good thing, but it could also not necessarily be a good thing if the scientist is too much influenced by worrying about who their audience is. And because in another part of science is criticism. And again, that's a sort of a feedback thing between the person who's creating and someone who might be listening. In my group, in my research group with my students, I try to be, I think we all try to do that. When we give criticism, we like to make it constructive. But I think that's a very important part of a research group. Or, the students in my group talk to each other and work together. But clearly, the way you communicate with people and talk about problems is a big part of being in a research group together.
And it's just an interesting dynamic, isn't it? I mean, none of us likes being criticized. I mean, nobody likes that. But it really actually impacts, in many ways, what you do, either consciously or subconsciously, because of what you think you're going to get feedback for it. So, of course, in a musical context, this happens in real time, right? You're playing something, you're trying to decide whether you're going to be safe or whether you're going to take chances. And one of the things, I used to teach quite a bit, and teach music, and one of the biggest things for the kids that I taught, and yet adults as well, was teaching them to take risks musically. Because, they were just learning a few little notes and whatnot. But actually, it was way more important that they learned to just sort of develop this go-for-it idea than that it was that they played something perfect. And that was hard to get people, especially that had learned classical music. I had a teacher named Miss Schutte who had a metal ruler. And if your hands weren't curved, she smacked you. Boy, your hands got curved. And I grew up with that. And I had to overcome this, don't play the wrong note. So I can appreciate where people are coming from in that. But it's really, really important. Otherwise, in jazz, what happens is you play it safe. Well, safe is boring in jazz, right? Safe ain't any fun. No one ever says, that's the predictable jazz musician. I like listening to him. No one, who wants to hear something? He played something wild tonight. That's what you want to hear, right? But not so weird that you didn't know what he was doing. So there's a real balance that you want to get through of creativity, living on that edge of trying a new thing. So we're going to try a new musical experiment on you right now. We thought it'd be useful for you to hear us put a whole song together. So we've talked about all these elements. You've been very patient to listen through molecules and atoms and phrases and chords. Well, how do we do this? Well, we're going to play Sunny Side of the Street, a song most people are familiar with, you'll recognize it. And we're going to do it jazz style, where we're going to do some of these things we talked about. We're going to play the melody, and then we're going to improvise a little bit over the melody. We're going to trade ideas, like we said before, and then come back around. Now, there's a whole shorthand of jazz musicians here that they understand this. I could walk in the room, literally, if they had another lecture like this next door and they need a piano player, I would just walk in and I'd say, let's play Sunny Side of the Street, it's a medium swing. Robert will take the head, we'll do a sax and a piano solo, then we'll trade fours and out. Got it? All right? Real easy, right? That's the shorthand. And that's,
We'll train with the drums this time.
we're going to play with the drums?
Every other one.
Everyone's with the drums. Here we go. Sunny Side of the Street.
2, 1, 2.
the Jasmine Quartet. And in fact, there really is a lot of fun, right? It looks like we're having a lot of fun, and that's the output. We don't make any acid amplifiers, we make groove amplifiers. As you can see, there's really, and I think, what was fun there for me, just a side comment, I mean, we played together 30 years, you can tell, Kenny. I don't know if you notice, our body language is like this. There is no substitute for that level of 30 years of collaborating. I mean, I can hear it before he plays it.
It's true.
He doesn't even know he's going to do it.
I'm gonna play.
That's another way, that's called marriage. Anyways, I digress. But seriously, this teamwork thing is really, really important. I mean, it's really what it's about. And as you invest in each other over time, you develop this deeper and deeper relationship. And it's true in chemistry and in jazz. Of the team is really important. And also, you'll notice that we call these things instruments, as I mentioned. We don't, they're actually tools. And so you have to have the right tool for the job. You've never heard the greatest tuba love ballads, right? No one's ever heard, harpsichord Michael Jackson.
You gotta hear ABBA done on the tuba.
There you go. It can be done, but not everybody raised their hand.
It should be done.
So, whether it should be done, yes, that's right. So the important thing is that you've got to have the right tools, and you've got to be aware of what you're doing. I'm sure it's the same in the lab.
Yeah, we have a variety of different tools that we use. So things as simple as just flasks to run our reactions, glassware such as a flask, a condenser. We also use more expensive things like a nuclear magnetic resonance machine.
I don't have one of those.
No, this is the same thing that people put their bodies in, magnetic imaging. It's the same thing. We use it in chemistry. And then the other thing is, of course, the exposure tools. I mean, the exposure tool that we have here in our facilities, $26 million piece of equipment, which I like to say that's a $26 million camera. I make the film that goes in the camera. That's my job.
Wow. So there are different jobs on the team, obviously. I mean, you notice each of us has a role, right? Angus is walking the bass, he's got the thing going, and he's got the groove happening with the thing, and I'm playing the chords, and he's playing the melody, right? Everybody has a piece, right? It would sound very different if Angus was playing the melody and I was playing the beat and he was trying to solo. It would be a whole different bag. So you really want to think about the different jobs on the team and how you hold up the different parts so that they all work together, and you want to assemble a team, obviously, where everybody's got a contributing role that fits the other people on the team.
Yeah, that's exactly right. And I think about my research group, and each of the graduate students have their own project that they're working on. And yeah, here's my group. One might be an expert in acid amplifiers. In fact, Seth Kruger is the graduate student in our group who's working on the acid amplifiers I talked about today. And we have Craig Higgins, who is an expert on thin films that are thin on a nanometer scale. And when we get into that size regime, things change in unexpected ways. And so he's studying that. And Brian, I mentioned earlier, his first experiment went the wrong way, and we discovered something new. And Sri has been a member of our group and is a postdoc and is an expert in chemical synthesis. And so she's helped bring that expertise into the group, and sort of had a role of a teacher a little bit. And Sarah Cruz was a summer intern as an undergraduate from Mexico, and she worked with us this summer. And she really, in addition to the nice research that she did, she also contributed to the group in a really nice way, in the sense that she was the student. So having her there allowed the graduate students to be the teachers, and gave them some new experiences along those lines.
And you actually have a second research group.
Yeah, my other group is the jazz quintet that Angus and I co-lead.
That's me in the middle.
So we have Angus, our bass player, and Bob Cassell, and Mike Nisberger is our guitar player, and Michelle Caminos is our vocalist. And obviously each one has their own role, and we've been having a lot of fun playing in the Albany area.
So actually,
sorry. Mistake. That was a mistake.
I can press that button too. He's just going to give it away. I want to set this up for a second before I start showing you the slide. So what I wanted to do to tie this together early on was I thought, well, why don't I take on the challenge of trying to compose a piece of music based on Robert's chemistry? So we spent $12 million, got a grant, and we haven't spent all of it yet, but I did buy some paper. And the rest of it, I'll tell you about what happened to it later. But quite seriously, I looked at the structure of his chemicals, and I tried to understand. What's happening here. So let me step out here and just kind of give you a brief analysis of this. I have a degree in composition, so I do have some understanding of how to put music together. Basically, this is the acid amplifier that Robert showed you. And remember, you have this body here, and you've got a trigger, and you've got the acids that come out. How'd I do? We practiced this yesterday.
Very good.
I missed it yesterday. I was doing this and this. But this is actually quite important for the composition because I was trying to figure out, well, how do you compose music to chemistry? And as I started to work through different options, I realized that what I had going for me was time. I have something that's happening in time. And so the act of creating music was the act of trying to express a reaction in time. And once I got that idea, I thought, okay, that's what I need to do. I need to show how the thing happens that Robert talked about, where the trigger takes the body and creates this acid output. And so what I did is I created a structure that I'll play for you that kind of hints at this idea. So first we start out with the basic body, just hanging out, minding its own business. It's, sorry, right? Okay, that's the first line. And then I add something to trigger. Right, something active, okay. And then at the top it starts to react. Play it again. Let's add something new. Experimenting, I'm getting some action, I'm getting some response. And then again, now I'm going to start adding more and more chemicals. Now I've got it going, and so now the acid's pouring out of it. Some more acid. So I've got the thing working. Right? I'm not playing the right notes, but that's all right. I played the bar ahead. And then there's a little trick. This note fits to the beginning. So, feels like it goes there. We're at the top again. That's the trick, so we can play this round and round, and we can create lots and lots of acid. So, this tune is appropriately named Nanology, and my band likes it at home in Seattle. We're going to add it to our book. So the experiment was a success because my audience, which is the band, liked it, and we're going to play it for you now. And we're going to feature myself and Robert and Angus. So we'll let him take a little solo on here. And it's kind of got a straight 8 feel. So are you ready? So here's Nanology world premiere. Nanology. Okay, 2, 3, 4.
So there was the world premiere of Nanology, and I'd like to wrap things up a bit by thanking Angus Mackey from bass. Marcel on drums. Nina, Kirsten, Melissa, and Steve for helping put this together. Professor Wilkoff for his lending me the movie, and I'd like to thank the college, the CNSC, and Key Bank for financial support. And on behalf of John and I'd like to thank you all for coming and being a lovely audience.
Thank you.
Happy to answer questions or
Questions?
yeah.
Were you reading, were you improvising or were you reading your notes?
The last part?
Any of them?
Half and half.
Half and half.
The melodies were played off the page, and the rest was all improvised.
So it was all improvised, because you
Yeah, just
looked
the
like you were
melody.
reading.
Hmm?
You looked like you were reading.
Yeah.
Well, he was reading the chord changes.
Oh,
What
okay.
he's reading.
Okay.
Oh, this thing. Okay, what he's reading is this is the shorthand: A flat 7 sharp 11.
Yep.
That's
So
the
we can play any
shorthand for
part
the
of-
chord, the
right.
musical notes that are legal.
Yep.
And
Right.
so,
Yep.
yeah. So that's what he's
Just
looking
wondered.
through the chord progression as we're playing. Make sense? Yes, question?
It's not a question, it's a suggestion which I hope to benefit from in this economy that sucks. I'm kidding, I'm kidding. But it's an excellent presentation today, but I would suggest you expand it and do similarity between jazz and natural sciences, because I can see jazz and biology when you showed molecule of caffeine and what else?
Chocolate.
Chocolate. I could see endorphins kind of slow and
can't we all?
caffeine as a stimulant, rush to the bathroom,
Yeah.
diuretic. So I think you opened the door for a very broad course, and it could be done for undergraduate students or for graduate students.
Yeah, you could.
Thank
Really,
you.
the theme of creativity is really the theme.
Oh, absolutely.
And then you apply it to almost any dimension.
Yes. Well, thank you, Arena, right?
Yes.
Yes. Thank you for your
Yes,
suggestion.
and if
and
you need
let's-
biology or diuretics, I'm here.
Okay. But let's talk. We have a break afterwards, so or a reception, so we can talk. Yeah.
Excellent.
Other questions?
Yeah, actually, it's just more of an observation regarding creativity and all. This is sort of a sidecar sort of train of thought, but something I've done a lot of looking into and thinking about. You know, as you know, John and I go back many years, working on lots of projects together. There is actually a recipe for creativity itself, and what I bring this up because like lots of folks who are, not musicians per se or something like that. Lots of people like the idea of being creative and all like that in whatever way it manifests itself for themselves. And it's not that it's necessarily a tried and true recipe, but it's something that has a long history of actually being successful for whatever field of endeavor you're in, to lead to ideas, to lead to creative things. It's basically 4 steps. I'll try to make this as brief, as non-geeky as possible. Basically, the idea is that you preparation. You get all your stuff together, all your materials, anything that that will lead you to deep thoughts about whatever it is that you're going to be working on or thinking about. The second step is immersion, and this is basically open-ended. You just plunge in and just dive in and immerse yourself in doing these experiments, whatever. You're in it, and you get down into this labyrinthine state of mind where you're just like really, really hyper-focused. And then the third, and what most people wouldn't necessarily think would be the obvious thing, is take a break and walk away and do something else, particularly something mundane, such as like doing the dishes or mowing the lawn or something like that. So you're gestating all this stuff that you have been immersed in for a while, and then all of a sudden the light bulbs will start to go off. And then the last step is capturing it, documentation. You have a pen and paper or something, a voice recorder, whatever, so that when the bulb goes off, you go, I got it.
Well,
because those thoughts are perishable. But this is, again, this is a long history of...
Well, I did this in my composition degree, and Robert, I think one of the things that makes Robert an excellent chemist and an excellent jazz musician is his ability to do this. I've watched him do this in both fields. In fact, we all know, those of us that know, that we don't have to bother him when he's immersed. He just gives off immersion technology.
Immersion vibes.
You'll notice the comment was about reading. That's the way he is immersed.
Yeah.
He's not casual with the material, and he's that way in his chemistry as well. So nothing about what you're doing, but you're doing the same thing as we're doing. So yeah, that's the secret. What happens? Who knows? Other questions or comments? Are you just scratching, or did you have a question?
Okay, well, thank you very much. We have a reception out here, and we'd be happy to continue the discussion out there. So thank you very much.